Hey guys, welcome back to part 3. So in this one, we're going to go through question 6 and question 7. So without further ado guys, let's go. Now, it says here that the curve C has equation y equals 2x minus 4 over x minus 3. Now write down an equation for the asymptote to C which is parallel to the x and y axes. Okay, cool. Before I even start this out, let's just draw a nice x-y axis graph here. So keep it nice and simple, just give it a little sketch here. Now, what you want to do, guys, is it's always helpful try and sketch this graph. Now, the easy way to plot these, and I'll be honest, it's actually quite easy, is to basically look at the numerator and the denominator and just, well, make them equal to 0 and find the root. Let's start at the bottom because that's how reciprocal graphs usually work. So if we make x minus 3 equal to 0, you're going to get x minus 3 equals 0, and therefore x is going to be 3. What this tells us is that when we plot this, we're going to have an asymptote at x equals 3. Now this only applies, we're going to look at this properly, but let's just call this one cos at x equals 3. That's what it's going to be. Likewise at the top, if you make 2x minus 4 equal to 0, which is write out neatly, and you solve it, you're going to get x equals 2. Now even though it says x equals 2, we're not going to write x equals 2 here. So what this means is that it's going to cut the y-axis, the asymptote on the y-axis will be at 2. So what I mean by that, just draw another dotted line here, and then call this line y equals 2. Even though I said x, that's just how it is, guys, yeah? And then all you got to do is just sketch it out nicely like that. So this just helps with, visualizing. Now, if you think about it, if we answer the questions, it says, write down an equation of the asymptote C which is parallel to the x-axis and the y-axis. Well, the one that's parallel to the x-axis is y equals 2. That's the line. And the equation is parallel to the y-axis, so here's the y-axis, is x equals 3. And that's really it, guys. That's literally both of these done. Now for the next one, find the coordinates of the point where C crosses the x and y axis. So in other words, you're looking at this point here and this point here. Easy way to do this, guys, well, is to just ask yourself, well, what happens when you cross an axis? If you cross the x-axis, this means y equals 0. If you cross the y-axis, it means x equals 0. So that's it. We just have to solve like that. So we can say, okay, therefore, let's let x equals 0. In other words, we're going to try and solve this part. So when x equals 0, what do we have? We're going to have y equals 0 minus 4, so just minus 4, over 0 minus 3, so minus 3. And that's it. That's basically just 4/3. So we can see that the first coordinate is going to be 0 4/3. So let's just write down nicely here, yeah? And then do the same for the other one, yeah? Now we're going to let y equal 0. So I'm just going to just do it here, around here. So let y equal 0. If you do that, you're just going to have basically the whole equation, 2x minus 4 over x minus 3 equals 0. Clearly, when you times x minus 3 across, you're just left with 2x minus 4 equals 0, and you're going to get a result of, just make that, we've done this earlier, you're going to get a result of 2. So the second pair is basically around 2, 0. So we just say 2, 0. And I was going to say, sketch C showing clearly the asymptotes and the coordinates of the points where C crosses the coordinate axes. Well, we already sketched it, and we've done it. So we know that one of them is going to be 2, 0, so 2, 0, so that's 2 across, 0 up. And the second one's going to be, 4/3. So we just put 4/3 there. And that's it, guys. Let's have a look what we have here. So a particle P moves along the x-axis so that at time t seconds, where time is always positive, the velocity of P, given by v meters per second, is 5 cos 2t. So that's an expression for speed, or velocity. Find the value of t when P first comes to instantaneous rest. So instantaneous rest just means when the speed is 0. So in other words, let v equals 0. That's it, okay? So that's basically means you're not moving anymore. Now to do that, just equate this to 0. So we're going to therefore have 5 cos 2t equals 0. And just solve it. Divide 5 across, you still got cos 2t equals 0. My personal advice is to keep your calculator again in radian modes, yeah? And now cos inverse this and then divide it by 2, you should have a result of t equals pi over 4 in your calculator. And then that's basically roughly 0.785 seconds. So that's it. So it basically goes instantaneous rest in less than a second. That's how quick this particle is. Now for part B, find the magnitude of the maximum acceleration of p. Now first things first, let's get to acceleration. How do you go from velocity to acceleration? Well, what you got to do is differentiate. There's like a certain rule here. When you always start displacement first. Let's call it s. S goes to v and then goes to a. This is the order of the differentiation. So if you had the displacement equation, differentiate to get v. To get to a, differentiate again. So we can say, alright, to get a, differentiate this equation. Focus on the cos 2t. Yeah? So let's ignore the 5. So leave 5 for a second. Cos 2t basically becomes a minus sine 2t. So let's put this in bracket, minus sine 2t. And then you got a 2 inside. So you differentiate that so you get 2 outside. So it'd be times 2. In other words, you're just going to get 5 times 2, which is 10. It's going to end up becoming minus 10 sine 2t. That's really it. Okay? So now we've got this value. It says find the magnitude of the maximum acceleration of the particle. So the maximum possible way. So you want the biggest possible value of this expression you can get here. And to get the maximum possible value, we just have to ask ourselves, what is the maximum value sine 2t can take? Now, if you think about it, guys, it's a sine wave, right? So if it's just moving like here and it's floating between minus 1 and 1, the maximum possible value of sine 2t would be 1. So in other words, the maximum value would be minus 10 times 1. So we could say that the magnitude of the maximum acceleration, so we do this kind of magnitude sign, is just going to be, and when you do magnitude, it's always positive, it will be 10 meters per second squared. That's all it is, guys. When you get sine or cos and they want to find the magnitude or the maximum value of this, it maxes out 1 for both of them. If it's minimum, it will be minus 1. So you times by minus 1. And that's it. Now for the next bit, it says when the time is 0, p is at the point A, where the distance OA is 0.2 meters. When p first comes to instantaneous rest, p is at the point B. Find the distance of OB. So what I'll do here, guys, is firstly, because we're talking about distance, we need to firstly get an expression for distance, or in this case, displacement. We already got v, so how do you go from v now to s? Well, if you went downwards, which is differentiation, to go back up, you integrate. So we're going to go ahead and integrate that equation, yeah? So let's just rewrite everything here. So part C, we know that the velocity was 5 cos 2t, okay? Now to integrate this, we're going to call it s. To integrate 5 cos t, just like how you differentiate, instead of, when you differentiate, cos becomes a minus sign. When you integrate, it becomes plus sign. And as for the 2, when you integrate, it goes underneath. So let's have a look. When you integrate this expression, you're now going to get, let's leave the 5 as it is, 5 sine 2t, and you're going to divide it by 2. And then we just write plus c. Now going back here, what's it telling us? It's saying that when t is 0, the distance is 0.2 meters. So let's go ahead and plug that in. So these are your initial coordinates. So we can say, okay, when t is 0, therefore the expression s, our distance we're going to use for now, is 0.2. Therefore, let's put this in. You're going to have 5 sine, remember just use your calculator for everything, yeah? Over 2 plus c must equal 0.2. Let's work this out. So sine 0 is basically 0. So in other words, all of that is 0. So therefore, c must be 0.2. Okay, that's cool, nice and easy. So now let's go ahead and update this equation. So we now have, okay, so the displacement equation is 5 sine 2t over 2 plus 0.2. Now back to the question, it tells us earlier that, so we've done this part, the first line, so always break into bits. It says when p first comes to instantaneous rest, so this is actually referring to part A, that's when instantaneous rest. And remember when that happened at t equals pi over 4, so let's make that note there. This is talking about when t equals pi over 4. And then that's how we know p is at the point B. It wants us to find the distance of OB. Okay, cool. So all it really wants you to do is just plug in pi over 4 for t. And I think that's really it. So okay, so we say therefore for distance OB, when t equals pi over 4, just plug it in. The distance is now going to be, and then again, just plug it all in and then put in your calculator. 2 times pi over 4 over 2 plus 0.2. And I did this already, guys, and I think you should get roughly 2.7 meters. And that's it. This should cover it all. And yeah, guys, as always, thank you for watching. I hope this video helps. And if you have any questions, drop into the comment section. Otherwise, I'll see you guys next time.